I'm now going to invite Polydor on behalf of Dr. Shibaki Ibrahim to give his talk on geopolymer bridge from construction and demolition waste, an area that I'm also very much interested in, demolition waste, that you know that it can be, I don't know about your talk, but it can be a good carbon sink. It's a bit disputable, but people think that demolished concrete and cementitious and silicated kind of materials are actually carbon sink. All yours.
Good morning, everyone. I'm going to talk about geopolymer brick from construction and demolition waste. Before I start, I would like to mention that it's an original paper test conducted by Polydor, Elijah, Mahmoud, and our supervisor, Mr. Shiao. This is the content, what I'm going to talk about today. Before I move to geopolymer and stuff, I would like to start from fire clay brick. We have to know that fire clay brick is one of the oldest manufactured production in construction. It started 4,000 years ago. But before fire clay brick, there was sun brick. So they was putting the brick in the water, and after they was drying with the sun. And after they realized that it was better to fry it, and that's why they call it traditional brick. And we have to know that it is up to 150 to 1,000 something. Yes, I think the fire clay brick is better. It's better because we are going to, it gives more strength, more density, and more durability. But the issue we have with fire clay brick, it takes a lot of time and also a lot of energy. That's why I'm here to talk about geopolymer. As you can see, I'm going to focus on 90%. There is 2%, 0%, 5%, and 2%. But I'm going to talk about 90%. Those 90%, there is too much inside. Our aim is to reduce the 90% because there is carbon emission. In the carbon emission, there is cement. We know cement is not good for the safety and for our environment. That's why our aim is to reduce the 90%. We're going to remove the cement, we are going to remove the fuel, and yes. I'm going to talk about the construction and demolition waste. Construction and demolition waste, we can find it in the maintenance, natural disaster, like earthquake. You can find it in construction and demolitions. In Europe, there is 924 million tons of waste. As you can see, also in the United States, there is 534 million tons. In China, our aim is to reuse the construction demolition waste. We cannot throw it and it will be a lot in the road. So our aim is to reduce those demolition waste and make it usable for everybody. Geopolymer. This is the second point. The geopolymer is the word introduced by Joseph David, a French guy, who gave this name in 1978. We have to know that for the geopolymer. This test has been used before us, and we are also trying to find the good alternative for everybody. But one of the big challenge for geopolymer or construction demolition waste is the proportion. The proportion is the same, so the data we are using, we cannot find it everywhere. That's why we base on Turkey. That is the main problem. Here in Cyprus, we cannot find everything, so we choose Turkey to find our topic. As I said, the limitation is to evaluate the mechanical property of the brick from construction and demolition waste. I was talking about the limitation. The limitation is we cannot find every gypsum, glass, brick. We can only find everything on Turkey. That's why we are focused on in Turkey, but we live in Cyprus. Okay, those are the material we use for our test. We use brick, concrete, glass, gypsum, and also water. As alkaline activator, we use sodium silicate and sodium hydroxide. Sodium silicate with liquids and sodium hydroxide powder. We have to know that we took the brick and we ground it up to 150 micro, and also concrete, glass, and gypsum. So it was a brick, we made it powder. And the liquid solid ratio was determined to have a probability for molding the sample. So we use a cube of 500 centimeters. So we use 6 cubes, 3 cubes for room temperature and 3 cubes for, 3 cubes for room temperature and other 3 cubes for 40 degrees. As you can see, so I would like to explain the procedure. After taking and grounding up to 150 microwaves, we combine all the sample and we put it in the cube, but we didn't use the machine for the compaction. We use hands, so we use our hand compaction, and after that we took our sample, we put it in room temperature for 24 hours. After that, we can put it in room temperature or in 40 degrees in oven. And the compressive strength at the age of 7 days or 28. We calculate, as you can see, we calculate the bulk density. So even if we put it in the oven, it was not dry. So that's why we calculate the bulk density. As you can see, those are the results we found. The effect of sodium silicate, sodium hydroxide, and also the compressive strength. We have to know that when we increase the sodium silicates, the compressive strength will also increase. So the strength will increase. So we don't need to put it in the oven if we increase the sodium silicates. So the oven just helps us to speed the process. The effect of increasing sodium hydroxide from 8 to 10 is neglected. The curing at 40 degrees gives high strength at the age of 7 days, as you can see. So the curing. For the recommendation, for the future research, we have to cover different curing methods and those stuff. But we are still working, we're still continue our work. That's why we need microstructure. We cannot remove all the voids in the brick. That's why we need microstructure to see what is inside. We need also the casting, we have to cast also in vacuum pressing machine to understand the effects of the void ratio. We also have to use fire resistance and durability for the study. Okay. Before I finish, the main problem we have is, as I was saying, is we cannot do our work properly because of lack of data. We are in Cyprus, I was saying we are in Cyprus, but we went in Turkey, so we took the data for the proportion for Turkey and we worked here. Those are the reference we use for our test and our thing. Thank you for everything.
Thank you, Polydor. Can I ask you to sit next to me in case we receive questions at the end of the panel? And may I take this opportunity now to invite